Tesla has long been the gold standard in battery innovation, dominating the game with unmatched capacity and efficiency. But now, a bold new contender has arrived, turning Tesla's much-anticipated Cybercell into yesterday's news. This revolutionary battery isn't just more efficient, it packs more power, boasts a larger capacity, and redefines practical usability. Curious about what Tesla is up against? Let's dive into the groundbreaking battery tech that's shaking up the EV world. So, who is QuantumScape? The genius behind this seismic shift? Meet QuantumScape, the Silicon Valley trailblazer that's giving Tesla a serious run for its money. Founded in 2010 by Jagdeep Singh, Tim Holm, and Fritz Prince, this company started as a scrappy little startup. That all changed in 2012 when Volkswagen, one of the world's biggest car manufacturers, took notice and teamed up with them, providing substantial funding. And it didn't stop there. Even Bill Gates saw the promise in QuantumScape and backed them with his own investment dollars. QuantumScape hit the headlines in 2020 when they revealed they were working on a game-changing battery that would leave conventional lithium-ion batteries in the dust. The buzz was immediate and global, with investors lining up to pour more money into the venture. But this raises a big question. What exactly is this revolutionary battery tech everyone's talking about? The answer is QuantumScape's cutting-edge solid-state batteries. Think of solid-state batteries as the next big leap in EV power. For years, they have been hailed as the future of electric vehicles, and for good reason. They share some similarities with traditional lithium-ion batteries. They're lithium-based too, but with a groundbreaking twist. Instead of using liquid or gel electrolytes like their predecessors, solid-state batteries rely on solid electrolytes, often made of polymers or ceramics. While this might seem like a small tweak, it's a game changer, delivering massive improvements in performance and utility. First, due to a much higher energy density, solid-state batteries have a way bigger capacity, which means they allow for a much greater range, while also being way lighter and more compact. This will allow the car to be much more drivable due to a lower curb weight and more efficient by not being overburdened by excessive weight. Essentially, this means we'll finally be getting range-efficient vehicles that aren't unnecessarily overpowered, meaning there will also be a considerably lower price tag for EVs in the future. What's even more interesting is the fact that despite being lighter, solid-state batteries allow for an even higher power output than regular lithium-ion batteries. This means we'll be able to exploit power even more and be able to create even faster electric vehicles. The cherry on top is the fact that solid-state batteries have a higher voltage tolerance, meaning charging times will be much faster than with regular lithium-ion batteries, which is once again one of the main drawbacks of electric vehicles compared to internal combustion engine cars. But the biggest reason why they're so much better than lithium-ion batteries is that they're also much more stable. The biggest concern that surrounds regular batteries is how easily combustible they are. Regular lithium-ion battery cells combine a flammable electrolyte with a significant amount of stored energy. Once the battery cell starts creating more heat than it can effectively disperse, the battery becomes very susceptible to spontaneous combustion. This process of producing excessive heat is known as thermal runaway, and it can be caused by short-circuiting, mechanical damage, and even overcharging or over-discharging. On the flip side, solid-state batteries are considerably more stable due to their inability to eject a range of flammable or toxic gases, since they're completely solid and lack any kind of easily flammable liquid that can rapidly vaporize. What's incredibly interesting about solid-state batteries is that they existed as a concept for almost 2 whole centuries. Michael Faraday was the first person to discover solid electrolytes back in the early 1830 seconds, which was the basis of all future development of solid-state ionics. This approach delivers immediate tangible improvements in range and efficiency for their current fleet. Furthermore, Tesla's immense advantage lies in its scale and its proven ability to manufacture batteries at a volume and speed that honestly no other company can match. Gigafactories around the world are already producing millions of cells. Even if QuantumScape's production facility comes online in 2025, it will take years to scale up to the output levels Tesla commands today. This head start in mass production is a critical moat that just can't be easily crossed. The ultimate future of electric vehicles likely won't be defined by just one battery type winning out. Instead, what we're probably going to see is a diversified ecosystem. Solid-state batteries might first show up in premium models and luxury vehicles, where their higher cost is justified by their superior performance and range. Meanwhile, advanced and continually improving lithium-ion batteries like the ones Tesla is producing will likely keep powering the mass market for years to come, becoming ever more affordable and accessible. In conclusion, QuantumScape's breakthrough has definitely thrown down the gauntlet, proving that solid-state technology is moving from the lab toward reality. This has energized the entire sector and accelerated development timelines everywhere. However, to declare that Tesla has been left behind is a profound misreading of the landscape. The true legacy of QuantumScape's challenge will not be the demise of a competitor, but the elevation of the entire industry. It's pushed every player, including the giant Tesla, to accelerate their own roadmaps. This fierce competition ensures that the electric vehicles of tomorrow will charge faster, travel farther, and become safer and more affordable than ever before, ultimately benefiting consumers and accelerating the global transition to sustainable energy. The race is on, and everyone stands to win. That said, change may be just around the corner. QuantumScape recently announced they're gearing up for mass production. Their factory is reportedly under construction and expected to be operational by 2025. If everything goes as planned, this could finally reveal whether QuantumScape's batteries are truly revolutionary. But let's not mistake QuantumScape's success for Tesla's failure. The EV industry is vast, and it's unlikely QuantumScape will have the solid-state battery market to itself. Tesla, along with other major players, will undoubtedly innovate, adapt, and push the boundaries of battery technology. The real winner in this race is electric vehicle enthusiasts, who will reap the benefits of cutting-edge advancement.
Energy density of a battery cell depends not only on the chemistry but also on the packaging. According to QuantumScape, a good cell design should aim to reduce the amount of dead weight and wasted volume taken up by other inactive materials, such as the cell casing, and increase the amount of active materials, the part of the cell that stores energy. This packaging efficiency is essential for achieving high energy density at the cell level, and the FlexFrame battery cell design considers this aspect. It uses lightweight pouch cell material and a low-profile frame that add minimal overhead to the cell. As a result, QuantumScape estimates that its new cell design can deliver an energy density above 800 Wh per liter in Q5. Its planned 5 amp-hour cell, with significant room for improvement in a higher capacity design. QuantumScape is convinced that solid-state lithium metal batteries are the future of electric transportation, and the FlexFrame architecture is its vision for that future. It addresses the unique challenge of lithium metal expansion, a key hurdle for any lithium metal system. It also boasts an elegant design that can offer good thermal performance and efficient packing at the module level while enabling high energy density at the cell level. Importantly, it is designed to allow for rapid mass manufacturing using materials and processes similar to those used at scale in today's battery industry. FlexFrame is a battery cell design that combines simplicity, efficiency, and performance, with the potential to revolutionize the electric vehicle market. What do you think about this? Let us know in the comments section.